This is a video for Module 8, Problem 7. So this is another one that looks a lot harder than it actually is. They tend to do that, right? So here we have a data in the accompanying table, which we're actually not going to use until we get down towards the bottom of this table, for various types of plots. We want to know, an agricultural researcher wants to know whether the mean number of plants for each plot type are equal. So first of all, when you choose your null and alternative hypotheses for this type of problem, your null on a ANOVA test is going to be that all of them are equal. So we have two choices here for equal. Your alternative is going to be that at least one of the means is different. And that's why they've chosen B here. So A has the correct null hypothesis, but doesn't have the correct alternative hypothesis. So we want all equal for the null, and then at least one of the means is different for the alternative. Now for B, I don't expect you, of course, to, memorize this. I don't think I've ever memorized it. But there are 4 requirements for to satisfy the one-way ANOVA procedure. So one way that you can just look this up to make sure that you know it, go to question help, and if you go to your textbook, it'll bring you right to the spot where they do the ANOVA testing. And you can see there's a nice little, I'm going to show you here where to find it, a nice little box here. I think they highlight it in purple. Let me see here. Yep, they do. That's the requirements for the one-way ANOVA test. So first of all, K must be simple random samples. They must be independent. They must be normally distributed, and they must have the same variance. So then you can go through and you can check off the correct boxes there. Now for C, again, this looks a lot more complicated than it is. They want to know, should the null hypothesis be rejected? And we already have the entire ANOVA table filled out for us. One thing they've also given us is the p-value, right? So remember, p and alpha are the ones that we look at when we do a p-test for a hypothesis test. And the saying is, if p is low, the null must go. So if p is lower than alpha, we reject the null hypothesis. Here, p is 0.001, alpha is 0.05, so the p is lower than alpha, so the null must go. P is low, the null must go. So we have two choices. To reject H naught, there is sufficient evidence to support H sub 1. Reject H naught, there is insufficient evidence to support H sub 1. Well, if we're rejecting H naught, then we're supporting H sub 1. So that's why we're going with letter B. Now for letter D, again, looks more complicated than it actually is. What you want to see here is the way that you kind of verify that one of them at least is different is that one of the boxes does not overlap the others. And you can really see here that spring disc is way over here. And the box does not overlap. Really, remember, the mean is going to be somewhere within this box because this line here is the median. It's not overlapping at all with these two, okay? So even though we don't know what the mean is, we know that, okay, they could be the same here because they're overlapping, but this guy's way over here. So definitely this supports our decision to reject H naught, that one of the means is definitely different. Okay, last but not least, we do have to do a little bit of work for this one to get our probability plot of the residuals. Now remember what a residual is. A residual is the distance from the mean, right? Now we don't want to calculate this, right? We don't want to go up to this table and calculate the mean for the whole data set and then, subtract the mean from every single data point. So we're going to let StatCrunch do that for us. So go up to click on the icon for the data table, and we're going to open this data. Here's all of our data here. We're going to open it in StatCrunch. I'm telling you, StatCrunch is a beautiful thing once you know how to use it. Okay, so first of all, we want to get those residuals and see the QQ plot. A QQ plot is your normal probability plot. So we're going to press Stat. We're going to go to ANOVA. We're going to go to One Way. Now we're going to select all 3 columns, sludge plot, spring disk, and no-till. You may have to press your Shift button, which I did to get all of these in one. And we want the QQ plot of the residuals and plus compute. And if you look here, like, oh, where's my plot, right? Go right over here to this little arrow, and there's your plot. Okay, now what I do when I compare this to things that are in my MyStatLab, I'm looking for something that's interesting about this QQ plot. And one thing that's kind of interesting here is that these 3 tend to be right together. So I'm going to look for one that has 3 that are like in a line like this. It kind of looks like I might be able to to find something like that. Now, one thing to make sure that you know, they put the residuals here on the y-axis and the normal quantile on the other, right? So looking at us, sometimes they kind of switch that on us in MyStatLab. So let's check. Yes, they did. Okay, so look here. The residuals are on the bottom and the z-score is on the side, right? That's that QQ, normal. Okay, so we need to think of this as flipping it over. Okay, so I know that can be kind of tough. So if you look, okay, we're looking for, I'm going to kind of go back over, 3 that are kind of on top of each other. And we got to kind of think of, okay, if I'm going from left to right here, and I want the values to be smaller, if I think of flipping this over, which one is that going to look like, right? So if I open this one, I see 3 together here. It makes me think that that might be it. But let's see, negative 1.9. This is close to 0. Let me look here. No, that's not near negative 1.9 at all, is it? That's near negative 0.5. Or negative 1. Oh, no, that's more. Yeah, that's not going to line up with negative 1.9. Okay, so that's not going to be it. Okay, this one here doesn't have 3 together at all, right? There's no 3 in the line, so that's not going to be it. And if I look here, oh, here we go, right? So I have 3 in a row, and it looks like this one matches up, right? So it takes a little bit of switching your thinking here because it is opposite of what you were seeing here. And how does the normal probability plot of the residuals show that the residuals are normally distributed? Again, you're always looking for that approximately linear relationship. So if you look at your data set here, they're all pretty much along that line. If they were scattered everywhere or there was some sort of U pattern, we would say, no, this is not normal. But this linear pattern leads us to believe that it's approximately normal.